Now we'll build our first ROS package, and we can use the terminal to build the basic boilerplate code for the ROS package. In our home folder, we have the Catkin workspace that we've created, and in there we have the source folder where we'll put all the ROS packages that we're creating. So we'll just navigate to that, cd Catkin workspace source. In here, we'll use the Catkin tools to make our package. Catkin create package. We'll give it a name, Hello Package. And we can also specify some dependencies. I'm going to build a C++ application, so I'm going to depend on ROS CPP here. All right. So basically what the tool did was to create the package XML, the cmakelist.txt, and some folders, the include folder and the source folder. You can see it all in here. And basically that's it. Now we have a ROS package because the package XML tells ROS that this is actually a package. Basically it's just a folder with some files in it and so on. But because it has this structure, it becomes a package to ROS. We can open this package in Visual Studio Code and in any other editor if you want to by saying open folder. We'll open the entire workspace here. And what you see is that under source we have our package, just as I just showed you. There's nothing in those folders, Hello Package and source here. But we'll start out by looking into the two files that it has made. So there's the package XML and the CMake list. We'll just collapse this. So first of all, in the package XML, we can specify a lot of extra information in order for ROS to treat this as the package it is. So you can give it a version and the description and so on. You can also put in your own name. I like to just go through the entire file and fill out with what I know already. We could make this an MIT license. You can see if you didn't really make any website for it, you can update it all later, and you can even remove these in order to keep the file a bit more compact. I am also the author. There we are. And then we have some of these dependencies. And as you can see, because I specified ROS CPP as a Catkin dependency, it is automatically put in both the build depend, the build export depend, and so on. What you could also do is that you could just, if you didn't specify it on the command line, you could actually just put it in afterwards, like so. It looks a bit nicer. And as you can see, there's different ways to depend on things, whether you are depending on it just for execution or just for building or for both. This is a shorthand for both. Probably you use this the most. Let's remove all the comments here. And then I'm not really exporting anything, so yeah, let's keep it unspecified, this export tag. There we are. Whoa. That's the package XML that we need for now. See, good. In the CMake list, we need to define what kind of executables that we have and a lot of other stuff. So this is actually the recipe to build our C++ node. And there's a lot of stuff that you can specify. First of all, I think that we need to make our C++ file before we can specify how to build it. So let's go and do that. We'll put it into the source folder here. And it can be confusing that we have two source folders, but beware that this source folder is in the Hello package here because the Hello package is a C++ package. And usually in C++ packages, you have a source folder for the sources. If it was a Python or some other type of programming language, you wouldn't have a source folder. The source folder here is because this is all the sources that you have written yourself. When we start building, you'll see that we'll have another folder for the build output. So we'll go into the source folder here and make a new file, and we'll call it hello.cpp. And inside of the hello CPP, we can just make an empty main function, right? So main, there we are, and we can output some things, right? We could output, oh, of course I need to include some things here. Include IO stream and std cout hello world. I think this is one of the most basic things that we can do. There we are. So this is now our Hello CPP. In order to build this, we need to go to the CMake list, and we need to tell it that this is a target for output. There's a lot of comments here that you can use to remember how to do this. But under the build heading here, we go and find the place where we declare a C++ executable, and we'll just remove basically the comment here. And then it has this project name _node source hello package node CPP. So I just called this hello CPP. When it builds this, it becomes the project name, which is hello _package, and this will become hello _package _node. And the reason why it has this prefix appended to it is because with the old Catkin build system, then it would collapse all the CMake lists. And if you had something that was called the same in two different packages, it would really, as it says here, it would collide. We'll make it sweet and simple, and we'll just call this hello. So that will be the name of our executable, or our target, sorry. In order to use this together with ROS, we need to link it. If you were quick, you saw that we actually didn't depend on ROS here. But of course, if you make a proper ROS node, it will. So we can remove the comments here and say that this specific target will be linked to the Catkin libraries that are found all the way up here with the find package Catkin, and it says find the ROS CPP. So you can find a lot of ROS packages, and all the libraries and include paths will be collapsed into Catkin include paths and libraries. The variable name that is signified by the $sign here. Okay, so now we built the Hello CPP, we linked it with the Catkin libraries. That's basically it. Actually, that will work. Later on, when your package is more mature, you can also tell where you want to install the executables and so on. But I'll leave this commented in for now, or commented out, sorry. So this should work. If you want to use the latest, or well, not latest anymore, but a newer version of C++, you can add this compile option. Okay, so now I saved it, and we can build it by going back to our terminal here, and we can call catkin build. There we are. So the first time you run this, it builds these pre-built Catkin tools pre-built, so it speeds up the compilation process later on. There we are. We built the Catkin package. Now we can go and source the setup bash file that is in, if you look here, in the Catkin workspace. Now, because we got these new folders, and in the development folder, we have these setup files, and we need to run those in order for the system to be aware that we have a new ROS packages inside this workspace. So we run source Catkin workspace devel setup bash. There we are. And then we can say ROS. Of course, we need to run a ROS core. There we are. And ROS run hello package, and inside that's only the hello. It says hello world. So this is our first package, and this is how you bootstrap your package with Catkin tools.